Welcome back to the deep dive. It feels like every other day there's a new headline about AI or someone's talking about how ChatGPT just did something incredible. For many of us, it can honestly feel a little overwhelming just trying to keep up.
It truly is a whirlwind.
Yeah.
The pace of innovation is just staggering, and, well, it's easy to feel lost in the sheer volume of information. That's precisely why we're taking this deep dive today into generative AI and ChatGPT.
Okay.
Our mission really is to cut through all that noise, distill the most important insights from sources like practical generative AI with ChatGPT, and give you the core knowledge you need so you can be truly well-informed about this transformative technology. We'll explore its foundational concepts, its evolution, and some cutting-edge applications.
So when we talk about AI, machine learning, deep learning, and then generative AI, how do they all fit together? It sounds kind of like a set of Russian nesting dolls, right?
Yeah.
Each one a bit more specific.
That's actually a perfect analogy, yeah.
Oh.
Artificial intelligence, AI, that's the broadest field. It's all about creating systems that can do tasks requiring human-like intelligence. Things like reasoning, learning, creativity.
Okay, the big umbrella.
Right. Now, machine learning, or ML, that's a branch within AI. This is where systems learn and improve from data over time. They automatically update their parameters, their settings to get better.
So ML is about learning from existing data, making things smarter.
Got at it.
And then we narrow down further into deep learning. How does that fit up?
So deep learning, DL, is a more specialized sub-branch of ML. It uses these deep neural networks, very complex structures. They're highly effective for tricky tasks like computer vision or natural language processing, NLP. And, historically, when we talked about ML and DL models, we often meant discriminative models.
Discriminative, what does that mean exactly?
They're designed to make predictions or classify existing data. Basically, they tell you what something is, like, is this picture a cat or a dog?
Okay, classifying or predicting based on what's already there. So how does generative AI fundamentally break from that? Why is that distinction so, transformative?
Right, so generative AI is a further sub-branch of deep learning, and here's the key difference. Unlike those discriminative models, generative AI uses these powerful artificial neural networks to create brand new content.
Brand new, like from scratch.
Exactly, from scratch. We're talking images, natural language, music, even video. These powerful models are often called large foundation models, or LFMs. It's not just about understanding data anymore, it's about making something entirely new.
That's a great way to put it. So the key differentiator then is truly creation generating totally novel content. And it's clearly moved beyond just text, hasn't it?
Yeah.
You mentioned images, music. It seems like generative AI has expanded into so many different domains.
It absolutely has, yeah. Generative AI has seen, significant advancements in applications across really diverse fields. Think art, music, fashion, architecture. In some areas, it's fundamentally changing how people create things. In others, it's making existing operations much more efficient.
Like text generation, which is probably what most people think of first with ChatGPT, right?
Yes, absolutely. Text generation is one of its most prominent applications. It can produce new natural language content, articles, poems, product descriptions, you name it. GPT-4o, for example, can generate really coherent, grammatically correct text in multiple languages. It can even pull out keywords or write full summaries. Oh, and a great example is explaining something complex, like what a proton is, to a 5-year-old using a Lego analogy. ChatGPT can do that.
Simplifying complex physics with Lego, that's brilliant. It's really amazing how far these models have come. What about images? That feels like another huge area.
Definitely. The field of image generation really took off, you could say, with a groundbreaking idea back in 2014. A researcher named Ian Goodfellow introduced generative adversarial networks, GNs.
GNs, right. I've heard of those.
These networks were designed to create super realistic images that are almost indistinguishable from real ones. And this capability quickly found business, uses generating synthetic data to train other AI, creating realistic product shots for e-commerce, enhancing VR and AR. And DALL-E, of course, has become almost synonymous with that kind of image generation now.
I remember when those early daily images started popping up, it was like, wait, is this real or Photoshop?
Yeah.
The progress has been dizzying. Almost feels like we went from stick figures to Renaissance art in like a blink.
It does feel that fast sometimes.
So we've got text, we've got images. What about music and speech? I've definitely heard some impressive AI-generated tracks and voices out there. How far has that come?
You're right to ask about the auditory side. AI tools for speech synthesis, so creating audio from text, can mimic well-known singers' voices. There are tools like fakeyou.com, uberduck.ai. The results can be surprisingly impressive. And taking it a step further, products like Suno. Have you heard of Suno?
I think so, yeah. It makes songs.
Exactly. It lets users generate entire songs from scratch just using natural language prompts. The goal is really to make music creation accessible to everyone, even if you don't have a musical background.
Making everyone a songwriter, that's quite something. And then there's the really mind-blowing stuff, like video generation. Is that also using GANs, or is that a whole new ballgame?
Video generation, yeah, it shares a similar development path with image generation. It often leverages GANs too, among other techniques. DeepMind has something called motion to video. It makes high-quality video from just a single image plus some motion instructions. And NVIDIA has video-to-video synthesis, vid-to-vid, which is focused on making videos that are temporally consistent, meaning the motion looks smooth and realistic over time.
Okay, so that's progressing too. Given how fast video is evolving, what's like the absolute cutting edge right now? What are you most excited about seeing maybe emerge from labs like OpenAI?
Well, what's really making waves right now is OpenAI's Aura. It was announced back in February 2024. It's a text-to-video model, and it's capable of generating these really realistic and sometimes quite imaginative videos up to a minute long. It's currently still in testing, with the OpenAI Red team before any public release. But the early examples, they're truly unexpected in their quality and creativity.
A minute-long realistic video from just text.
Wow.
It's amazing to think about how quickly this is all developing. But how far back does this research actually go? I mean, it can't have just popped up in the last few years, right?
That's a great point. No, not at all. While the recent explosion feels very new, the journey goes back decades. You could mark the beginnings, maybe, in the 1960s with Joseph Weizenbaum's Eliza. Remember Eliza?
Vaguely, yeah. The therapist chatbot.
Sort of, yeah. One of the very first NLP chatbots. It was simple, rules-based, really basic by today's standards, but it paved the way. It opened the door for future work in NLP and conversational AI.
So Eliza was like the conversational icebreaker that started it all. But modern generative AI relies on neural networks, right? Which feels like a much more recent thing.
Well, yes and no. The first artificial neural networks, ANNs, were actually introduced way back in the 1940s.
The 40s? Seriously?
Seriously. But early researchers faced huge challenges. Limited computing power was a big one. It wasn't really until the 1980s, with the invention of the backpropagation algorithm, a key way to train these networks, and then later, in the 2000s and 2010s, with massive jumps in computing power and huge amounts of data becoming available, that's when deep learning truly became practical.
Okay, so the ideas are old, but the tech needed to catch up. What were some of the big breakthroughs then, the milestones that really got us to where we are today with generative AI?
Several key milestones stand out. 2013, Kima and Welling introduced variational autoencoders, VAEs. These are generative models that learn these compact representations of data. They encode data down into a smaller latent space and then decode it back. Think of it like taking photos of cats and dogs, compressing them to their essential catness or dogness, and then generating new realistic cat or dog pictures from those essences.
Okay, so VAEs compress and then recreate.
Yeah.
And then came GANs just a year later.
Yes. 2014, Ian Goodfellow introduced GANs. They use a different architecture. You have a generator network creating content and a discriminator network trying to tell if it's real or fake. They compete, and the generator gets better and better at fooling the discriminator, leading to incredibly realistic results.
Like an art forger and a detective constantly trying to outsmart each other.
Exactly. That's a great analogy.
But the real game changer for language, the one that underpins models like ChatGPT, that was the transformer architecture, wasn't it?
Yeah. Absolutely. The revolutionary transformer architecture. Introduced by Google researchers in that famous 2017 paper, Attention is All You Need. It was a game changer because it allowed for parallel processing of language data, unlike older models like RNNs or LSTMs, while still keeping track of context using this attention mechanism. It massively outperformed previous models. This architecture became the foundation for Google's BERT in 2018, and crucially, for all of OpenAI's GPT models.
Which brings us neatly to 2022, which some people called the year of generative AI. Why was that year so pivotal? What happened?
2022 was really the year these powerful AI models burst into the public consciousness. They became widely available. We saw diffusion-based image generators like Midjourney, DALL-E 2, Stable Diffusion. OpenAI launched ChatGPT, of course.
Right.
Text-to-video tools like Make a Video and Image in Video appeared, even text-to-3D tools. The impact was huge because it democratized access. Suddenly, anyone could play with these incredibly powerful tools without needing to be a data scientist.
Right. It wasn't just researchers anymore.
Exactly. And the results, the creativity were stunning, sometimes even a bit concerning. It prompted this urgent call for adaptation from individuals, companies, governments, everyone. The key insight here, I think, is that it wasn't just a technological leap, it felt like a societal inflection point. It forced this rapid reckoning with AI's potential and its perils across every sector.
A real turning point. So fast forward 18 months from ChatGPT's launch in November 2022. What are the main trends and innovations we're seeing now? I know there are new models coming out constantly.
You're right, the pace hasn't slowed. We're seeing a continuous stream of new models. OpenAI's GPT-4o, DLE-3, Google Gemini, Meta's Llama 3, Microsoft's Phi 3, list goes on. But arguably, the most remarkable achievements lately lie in how we interact with these models and build applications around them. I'd highlight maybe three key advancements shaping how we build generative AI apps now: retrieval augmented generation, multimodality, and AI agents. Oh, and also significant progress with small language models.
Okay, let's unpack those. Retrieval Augmented Generation, or RE. You mentioned earlier that a big limitation of LLMs is their knowledge cutoff, right? They only know what they were trained on, which gets outdated, and they don't know my company's specific info.
Precisely. Their knowledge is limited to the public data they saw during training. It's finite, not always current, and crucially, lacks any proprietary or private information. Like your example, asking ChatGPT about your specific company's health insurance policy. It just wouldn't know.
So what's the clever solution? How does RA bridge that gap between the LLM's static knowledge and the real-time specific data we actually need?
That limitation makes perfect sense, yeah. RAG is the clever solution. It basically decouples the LLM from the knowledge base it needs. Oh, well, the external data, your company, documents, recent articles, whatever, is transformed into embedding.
Embeddings, those numerical vectors you mentioned.
Exactly. Numerical vectors that capture the semantic meaning, the essence of words or sentences. These embeddings are then stored in a special kind of database called a vector database. The cool part is, if two pieces of text are semantically similar, their vector representations will be close together in this database space. Remember the king man plus woman, a queen example?
Yeah, that vector math thing. Amazing.
That's the core idea. It maps meaning into geometry.
Okay, that's a fantastic analogy. So how does this RAG process actually work then when I ask the LLM a question that needs this external knowledge?
It generally happens in three main phases. First, retrieval. When you ask your query, its vector representation is used to search the vector database and find the most semantically similar documents or text chunks.
So it finds the relevant pieces of information first.
Right. Second, augmentation. The retrieved information is then bundled together with your original query and often some additional instructions, rules, or safety guidelines. This whole package becomes the enriched context for the LLM.
Okay, prepping the input.
Exactly. And finally, generation. The LLM takes this augmented context and uses it to generate its response to your original query. The really strategic insight here, especially for businesses, is that RE lets LLMs use vast amounts of up-to-date proprietary or domain-specific data without needing costly retraining. That makes them incredibly powerful for internal knowledge tools, custom chatbots, all sorts of things.
That's a huge leap in making these models genuinely useful day to day. Okay, what about the second trend you mentioned? Multimodality. That sounds like it involves more than just text.
It absolutely does, yeah. Historically, large foundation models, LFMs, tended to be domain-specific, like you had large language models for text, DALE for images.
Yeah.
Multimodality represents this shift towards large multimodal models, LMMs. These can process and generate diverse types of data, text, images, audio, video, sometimes even code or other formats, all within a single model.
So one model handling everything, like how humans use multiple senses.
That's the idea, to mirror how humans interact with the world using all our senses.
So like GPT-4o, for example, is that multimodal?
Precisely. OpenAI's GPT-4o is a prime example of an LMM. It can, say, analyze an image you upload, understand its content, and then reason about it. You could show it a picture of the Eiffel Tower, ask what it is, and it'll tell you. Then you could ask it to generate a cartoon-style illustration of the Eiffel Tower, and it would create it. It can even, apparently, take an image of a crossword puzzle and solve it for you.
And solve a crossword from a picture. That's incredible.
It opens up a vast landscape of new applications combining vision, language, and generation.
That's truly mirroring human interaction. Okay, what's next? You mentioned AI agents working together. This sounds like sci-fi. How do these agents collaborate effectively? And what are some of the maybe unexpected benefits or challenges when you have multiple AIs working together?
This is a really fascinating area, still quite experimental, I should say, but showing huge promise. AI agents, the concept is basically having multiple LLM instances or agents collaborating to accomplish a complex task. Each agent is given a specific role and may be equipped with different tools or plugins like web search access or the ability to run code.
So like a little AI team, each with their own specialty.
Exactly. Imagine you need a really good elevator pitch about, say, climate change solutions. Instead of asking one LLM to do everything, you could have a team, maybe a market analyst agent that uses web search to find current trends, an expert researcher agent with access to scientific paper databases like ArcStove, a public speaking expert agent to craft the actual pitch, and maybe even a critic agent to review the output and suggest improvements.
Wow, that sounds like it could unlock some incredible problem-solving power, but also maybe new complexities in managing them.
For sure. Frameworks are emerging to help manage this, things like AutoGen, LangGraph, Crew AI. They help define the workflow and how the agents interact. While it's still early days, this multi-agent approach is already showing some outstanding reasoning capabilities and new ways of tackling complex problems. The key challenge, as you hinted, is coordinating these agents effectively, making sure they truly work together synergistically towards the common goal, not just talking past each other. But the potential is enormous.
Fascinating. Okay, the last trend you mentioned was small language models, SLMs. This sounds like the opposite of the huge LMs we usually hear about. Why are these smaller models gaining traction? What does that mean for the AI landscape?
It's a really important counterbalance, I think. While the giant LLMs, some with trillions of parameters, offer incredibly impressive reasoning, they come with significant costs. We're talking very high training and hosting expenses. You need serious AI infrastructure. And there's a substantial energy consumption footprint, which raises real questions about environmental impact and long-term sustainability. Just for context, training a model like Bloom 175B, that's 175 billion parameters, was estimated to emit something like 183 tons of CO2 equivalent.
Wow, that's a lot. So SLMs are potentially a greener, more cost-effective alternative.
Potentially, yes. There's growing interest in research into developing smaller models that can still maintain decent reasoning capabilities, often by specializing in more tailored tasks, rather than trying to be a general know-it-all. They might have just a few billion parameters instead of hundreds or trillions. And here's the surprising part. Some results are showing that smaller can sometimes be better, or at least competitive. Microsoft's Phi-3 small model, with only 7 billion parameters, has been shown to outperform the much larger GPT 3.5 Turbo, which has 175 billion parameters, on several popular benchmarks.
Really? A 7 billion parameter model beating 175 billion one? How?
Well, it suggests that smarter training data, better architecture, or focusing the model might be more important than just raw size for certain tasks. The profound insight here, I think, is that the future of AI probably isn't just about these massive generalized models. It's likely a strategic shift towards more efficient, specialized, and perhaps more sustainable AI solutions tailored for specific needs. It really challenges that notion that bigger is always better in AI. It's definitely a research stream to keep a very close eye on.
That's a really interesting counterpoint. Okay, shifting gears a bit, let's talk about OpenAI itself and how we as users can actually interact with these models, especially ChatGPT. What's OpenAI's core mission again?
So OpenAI, founded back in 2015, states its mission is to ensure that artificial general intelligence, AGI, benefits all of humanity. AGI, that's defined as the ability for an AI to learn and perform a wide range of intellectual tasks, essentially any task a human can, without needing specific programming for each one. True generalized intelligence.
That benefits all of humanity. That's a pretty bold mission statement.
It is. It sets a very high bar. And when you think about AGI benefiting all of humanity, it really raises the stakes for everything we've been discussing: bias, access control, safety.
Absolutely. So what are the main types or families of models that OpenAI offers right now?
They have several key families. Their flagship, of course, are the GPTs, the generative pre-trained transformers. These are the language models like GPT 3.5 Turbo, GPT-4, and the latest GPT-4o and its smaller sibling, GPT-4o Mini. They also have some legacy-based models still available. Then for images, they have DALL-E for generating and manipulating visuals from text prompts. In the audio space, there's Whisper for very accurate speech recognition, and text-to-speech, TTS, models for converting text into high-quality spoken language. For video, as we mentioned, they have Sora, their text-to-video model, though it's not publicly available yet.
Got it. I've also heard about embeddings and moderation models. What are those used for?
Right. Embeddings models like text embedding ADA002 or text embedding 3 large are crucial. They transform text into those numerical vector representations we talked about, capturing semantic meaning. This is incredibly useful for tasks like intelligent search, clustering documents, measuring text similarity. That king-man plus woman-queen relationship lives in this vector space. And then there are moderation models like text moderation 007. These are specifically designed to detect and filter out potentially harmful or inappropriate content across various categories: violence, self-harm, hate speech, harassment, explicit content, and so on. They act as safety filters.
Okay, that makes sense. So how do we as users actually interact with these models, especially if we're not coders?
Yeah.
Is there like a user-friendly interface?
Absolutely. OpenAI provides the OpenAI Playground. You can find it at platform.openai.com/playground. It offers a really user-friendly web interface where you can experiment with different models, tweak parameters, and see the results instantly, all without writing a single line of code. Of course, for developers or those who prefer a pro-code approach, all the OpenAI models can also be accessed and integrated into applications via REST APIs.
The playground sounds like a good starting point. What are some of the key terms or concepts we need to know in using it?
Yeah, there's some jargon. Tokens are fundamental. Think of them as word fragments, the basic units the AI processes. Podcast might be one token, but a longer word like transformer might be broken into transform and two tokens. Roughly maybe three-quarters of a word in English on average.
Okay, so tokens are like the AI's building blocks.
Exactly. A prompt is simply your text input, the instruction or question you give the model. Context refers to the words or conversation history that comes before your current prompt. The model uses this context to predict the most likely next words. Model confidence indicates how certain the AI is about its prediction for the next token. And functions, or sometimes called tools or plugins, are essentially external capabilities you can give the model access to, like web search or code execution.
Right. And can you tweak how the model responds, like make it more creative versus more factual, or control the length?
Yes, definitely. You can configure several parameters in the playground or via the API. Temperature is a key one. It controls randomness. It usually ranges from 0 to 1, sometimes 2. A low temperature, like 0.2, makes the output more focused, deterministic, maybe better for factual answers. A high temperature, like 0.8 or 1.0, encourages more diversity, creativity, sometimes even unexpectedness. Max tokens sets the maximum length of the generated response in tokens. Stop sequences are specific words or phrases that tell the model to stop generating, even if it hasn't reached the max token limit. And then there are frequency penalty and presence penalty. These help control repetition. Frequency penalty discourages repeating the same words too often, while presence penalty discourages introducing topics or concepts that have already been mentioned. They help make the output less repetitive and more varied.
Lots of knobs to turn. Okay, let's talk about ChatGPT itself. It launched November 2022, exploded onto the scene, reached 1 million users in just 5 days, which is just insane. What made it so impactful so quickly?
Its immediate impact was undeniable, yeah. The first release was built on GPT 3.5, but crucially, it was fine-tuned specifically for dialogue. A key part of that fine-tuning process was reinforcement learning with human feedback, or RLHF.
RLHF, I've heard that term. What does it actually involve?
It's a technique where human reviewers provide feedback on the model's responses. They might compare two different answers to the same prompt and choose the better one, or rate responses for helpfulness, honesty, and harmlessness. This human input is then used to train a separate reward model, which in turn helps fine-tune the main LLM to produce outputs that align better with human preferences and desirable conversational behaviors. It makes the model more helpful, less likely to make stuff up, and safer. InstructGPT, a predecessor to ChatGPT, really pioneered this approach, showing how it can make models much better at following instructions in English.
So human feedback directly shaped it to be a better conversationalist.
Yeah.
And it's still free, right? But there's also a paid version, ChatGPT Plus.
Correct. ChatGPT is still available as a free application, which is amazing. But since February 2023, they've offered ChatGPT Plus, the paid subscription, currently around $20 a month. Subscribers get several benefits: access to the latest and most capable models like GPT-4o, generally faster response times, especially during peak hours, access to a growing set of integrated tools or plugins like web browsing and data analysis, and the ability to create and use custom assistants, known as GPTs.
And the interface itself, what's that like?
The interface is pretty intuitive. You have model selection, you can see some pre-built prompt examples, there's the main text box for your input, your chat history is saved on the side, and there are options for sharing conversations or creating shared workspaces. Plus, as mentioned, the Plus version comes with those powerful built-in capabilities like web search and the code interpreter, now often called data analysis, that the model can decide to use on its own when needed.
That's a lot of power at your fingertips. Now, to really get the most out of these incredible tools, we need to talk about prompt engineering. It sounds fancy, but what exactly is it?
Yeah, prompt engineering. It sounds technical, but it's basically the art and science of designing effective inputs, prompts, to guide large language models towards the desired output. It's crucial not just for getting better, more relevant responses, but also, importantly, for reducing risks like hallucination. When the model confidently states something that's just plain wrong or generating biased content. As the old computing saying goes, garbage in, garbage out. It applies perfectly here. The quality of your prompt heavily influences the quality of the output.
So it's really about crafting the perfect question or instruction. Are there different kinds of prompts we should be aware of?
Broadly, yes. We often differentiate between user prompts and system prompts. A user prompt is what you, the user, directly type into the chat window, your specific question or request. A system prompt, sometimes called a meta prompt or back-end instruction, is a set of instructions given to the model beforehand, often hidden from the end user. It tells the model how to behave generally, its persona, its constraints, its overall goal, regardless of the specific user query that follows. Think of it as setting the stage or defining the AI's role.
Okay, so system prompts set the rules of engagement. What are some core principles then for writing good prompts, user prompts, mostly to ensure we get quality output and avoid that garbage out?
There are several good principles. The first, and maybe most important, is providing clear instructions. Be explicit. This means clearly stating the task's goal, specifying the desired format or structure for the output, like answer in bullet points or write in a formal tone, mentioning any constraints, keep it under 100 words, don't use jargon, and providing necessary context. For example, if you want a tutorial for making pesto, just asking how to make pesto might give you a paragraph. Asking, generate a bulleted list tutorial for making traditional basil pesto aimed at beginners will likely give you a much more useful, structured response. And if the model can't fulfill a request based on its instructions, it should ideally acknowledge that instead of guessing.
Be specific, give context, define the format. Got it. What if the task is really complicated or feels a bit ambiguous?
In those cases, it's often best to split complex tasks into simpler subtasks. Break it down. For instance, asking an LLM to summarize this long research paper might be too vague. You could instead break it down. First, extract the key findings from this paper. Second, rewrite these findings in simple language. Third, combine them into a single paragraph summary under 150 words. GPT-4o, for example, can often explicitly show this kind of decomposition in its reasoning process when asked to do something complex, like summarizing an article by identifying steps, like read the article, identify main topic, generate summary. Breaking it down helps the model stay on track.
That makes sense. Break it down for the AI just like you might for a person learning something new. What about preventing the AI from just confidently making stuff up? That hallucination problem seems like a big one.
It is a challenge. One technique is to ask for justification. Force the model to explain its reasoning. LLMs fundamentally are just predicting the next most likely word or token. They don't inherently know if what they're saying is true, and they don't easily review their previous output for consistency like humans do. This can lead to those confident but incorrect statements. By explicitly prompting the model to explain your reasoning step by step or justify your answer, you encourage it to follow a more logical path and make it easier to spot potential errors. It also helps you understand how it arrived at the answer, even if the answer itself is correct. For example, if you give it a riddle, don't just ask for the answer. Ask for the answer and an explanation of why that's the correct answer based on the riddle's clues.
That's smart. Force it to show its work. Okay, if it can't easily self-correct its own mistakes during generation, how else can we increase the chances of getting a good, accurate answer, especially for more creative or open-ended tasks?
A useful strategy here is to generate many outputs, then pick the best. Or even better, have the model help you pick the best. Since LLMs generate text sequentially, if they make an unlucky or poor choice early on, pick a less probable but plausible token, the whole rest of the response can go off track. They don't easily backtrack. So instead of just asking for one answer, you can prompt the model to generate, say, 3 or 5 different responses to your prompt. Then you can either review them yourself Or you can add another instruction in the prompt asking the model itself to evaluate its own generated responses based on certain criteria, like accuracy, creativity, relevance, and select the best one. For that riddle example again, you could ask it to generate 3 possible answers with justifications, and then add, review the 3 answers and select the most plausible one, explaining your choice.
Let it generate options and then act as its own critic. Clever. And finally, you mentioned system prompts earlier. How do we structure these prompts, especially if they have multiple parts or instructions, to make them really clear for the model?
Good question. Clarity is key, especially for longer or more complex prompts. A best practice is to use delimiters. Delimiters are just specific characters or sequences of characters like triple backticks, XML tags, example, dashes, or even just distinct headers like instructions that you use to clearly separate different sections or types of information within your prompt. This helps the LLM parse the input correctly and understand the distinct parts. Here are the instructions, here's the input data, here is an example output format, etc. It structures the prompt visually and logically. For instance, when asking it to generate Python code based on an example, you could use delimiters to clearly mark off the user query example, the expected Python code output, and the actual new query you want it to process.
Using delimiters to create structure. Got it. Okay, those seem like really solid foundational principles for prompt engineering. Are there more advanced techniques people are using to get even deeper reasoning or handle more complex workflows?
Yes, absolutely. The field is evolving fast. One powerful technique that's become quite standard is chain of thought, or COT prompting. COT, introduced by researchers like Wei and colleagues, basically involves prompting the LLM to think step by step or generate intermediate reasoning steps before giving the final answer. This encourages the model to break down the problem and follow a more logical sequence, making it much better at complex reasoning tasks like solving math word problems or multi-step logic puzzles. It also makes its reasoning process transparent. So for solving a simple equation like 2x plus 3 equals 11, instead of just spitting out pi less 4, a COT prompt would encourage it to show the steps. 1. Identify the equation, 2x plus 3 equals 11. 2. Isolate the variable term. Subtract 3 from both sides minus 2x equals 8. 3. Solve for x. Divide both sides by 2 minus equals 4.
Okay, so chain of thought is about showing the internal reasoning steps. How does that differ from another term I've heard, react?
Good question. REACT, which stands for Reason and Act, developed by Yao and others, is a slightly different and often more powerful paradigm. It combines reasoning with taking actions and observing results, often interacting with external tools. While COTE focuses purely on generating internal thought steps, REACT prompts the LLM to cycle through a thought-action-action input observation loop. The model first thinks about the problem, then decides on an action, like searching the web, querying a database, running code, specifies the action input, for example, the search query, then receives an observation, the result of the action, like search results, and then loops back to think based on the new information. Remember that climate change elevator pitch example with multiple agents. A single agent using the REACT framework could achieve a similar outcome by reasoning about what information it needs, taking actions like web searches or looking up papers, observing the results, and iteratively refining the pitch. It makes the LLM much more dynamic and capable of interacting with the world to solve problems.
That sounds incredibly powerful, letting the AI use tools and learn as it goes. Okay, so we've covered the foundations, the history, the latest trends, and how to effectively talk to these models through prompt engineering. Now, let's get really practical. How can ChatGPT be used in the real world? Starting simply, maybe just as a daily assistant?
Oh, definitely. As a daily assistant, ChatGPT can be incredibly versatile. It can help organize your meeting agendas, brainstorm meal plans for the week, even help you find specific information buried in documentation you upload. That act as prompting technique is really useful here. You can tell it, act as an expert meeting facilitator and help me create an agenda for my team meeting, or act as a nutritionist and suggest healthy lunch ideas. It can even act as a personalized tutor or professor for exam preparation. You can ask it to quiz you on, say, concepts from microeconomics and then provide feedback on your answers.
A personal tutor on demand. And for generating text, beyond just answering simple questions, what kind of creative or practical writing can it do?
It really excels at generating new content from scratch. You can ask it for articles on almost any topic, poems in specific styles, scripts for videos or presentations, even detailed theater dialogues complete with character descriptions and sonography instructions. It's also great at manipulating existing text. It can shrink text, for example, taking a lengthy blog post and condensing it into a concise summary suitable for an X post, formerly Twitter, or a LinkedIn update.
Or polishing existing content, maybe, making it sound better.
Exactly. It's fantastic for improving existing text. You can ask it to change the style, make the sound more formal or more casual or more persuasive, or adapt it for different audiences. Imagine you've drafted an email inviting people to a webinar. You can feed that draft to ChatGPT and say, rewrite this invitation for a senior executive audience, and then now rewrite the same invitation for a high school student audience. It will adjust the tone, vocabulary, and emphasis appropriately for each. It can also provide really valuable feedback on your own writing style and consistency. You could paste in an essay introduction and ask, critique this introduction. Is it engaging? Is the thesis clear?
That's like having an editor on call. What about translation? We know tools like Google Translate exist, but how does ChatGPT compare, especially with nuances like idioms or slang?
Its translation capabilities are generally quite strong, yeah. It can usually automatically detect the source language and translate into many different target languages. And crucially, it often does a better job than traditional machine translation tools at capturing the refined meanings of slang, cultural references, and idioms. For example, translating the British idiom, it's not my cup of tea, into Italian. A more literal translation might be confusing. ChatGPT is more likely to provide several nuanced Italian equivalents that capture the meaning that something isn't to your liking, rather than just translating the words literally. It can even translate text while adopting a specific tone you request, like translate OpenAI's mission statement into French but make it sound sarcastic.
Wow, sarcastic translations. That shows a real understanding of intent and context. How about using it for more business-focused tasks like information retrieval or competitive intelligence?
It's a really valuable assistant for market research, definitely. You can ask it to generate lists of competitors for a specific product or service. For instance, list the main competitors for introductory books on convolutional neural networks implemented in Python. You can ask for advice on market saturation in a niche, or prompt it to suggest ways to make your planned product unique. For that CNN book example, it might suggest focusing more on real-world case studies, adding interactive coding notebooks, or including a chapter on the latest explainability techniques and ethical considerations, things that might differentiate it. Now, you do have to remember the knowledge base cutoff for the core model, often around 2021 or 2023, depending on the version. But when combined with its built-in web search capability in the Plus version, it can access current information and still provide excellent analysis, best practices, and valuable insights for strategic thinking.
That's a huge time saver for anyone doing market research or product planning. Okay, let's switch to developers. You hear a lot about AI helping coders. Can it really be a useful code companion?
Oh, absolutely. For developers, ChatGPT and similar models are becoming indispensable tools. It can handle code generation surprisingly well. You can describe a concept, sometimes even show it an image of a UI element, and ask it to generate the draft code, say HTML, CSS, and maybe even some basic JavaScript for a simple game like Pac-Man, just based on a description or image.
From an image to working code. That's wild.
It can be. It's often a starting point, needing refinement, but it's powerful. It also excels at code optimization. You can give it a working piece of code, like a Python script that finds odd numbers using a simple loop, and ask it to make it more efficient or more Pythonic. It might suggest using list comprehensions or the filter function, explaining why those are often preferred and faster.
And the debugging, that's often the most frustrating part of coding. Can it help there?
It's a lifesaver for error explanation and debugging. You can paste in a confusing error message from your Python console, for example, and ChatGPT will often explain what the error means in plain English, suggest likely causes, and point you towards how to fix it. You can also give it buggy function, explain what it's supposed to do, and ask it to find the bug and provide the corrected code. It's like having a patient, knowledgeable pair programmer available 24/7. Beyond basic debugging, it can assist with ML model interpretability. You could describe the layers in your neural network architecture, like a CNN for image classification, and ask it to explain the purpose of each layer, or paste in your training and validation loss curves, and ask for an interpretation of what they might indicate about the training process.
That's incredibly useful. And what about translating between different programming languages? You mentioned that earlier. That sounds like a potential dream for companies dealing with old legacy code.
It really is a game changer for bridging skill gaps and tackling application modernization projects. ChatGPT can translate code between various programming languages with reasonable accuracy. Think about converting Python algorithms to JavaScript for a web application, or, more dramatically, translating decades-old COBOL code from a mainframe system into modern C# or Java. This capability can massively accelerate efforts to update legacy systems or allow developers to work on projects using languages they aren't yet experts in.
A universal translator for code.
Hmm.
Okay, moving from code to creative. How about for marketers? How can ChatGPT boost creativity and help with marketing strategy?
Marketers can really tap into ChatGPT's creative power. For personalized marketing, for example, it can help analyze customer data segments, if provided appropriately and ethically, and generate tailored email subject lines, ad copy, or promotional messages designed to resonate with specific groups, potentially increasing conversion rates. It's also great for new product development and go-to-market strategy. You can use it as a brainstorming partner. Ask it for new product ideas in a certain category, suggest catchy names and slogans like your Green Stride example for eco-friendly running socks, help identify target audiences, propose different product variants, or suggest potential sales channels. It can even help articulate the unique selling proposition. And of course, DALL-E can be used alongside it to generate initial marketing visuals or mood boards directly from text prompts.
So it's like having a whole creative agency brainstorming session on tap. What about more tactical things like A/B testing?
Yes, exactly. For A/B testing, it can rapidly generate multiple variations of marketing content. Need 5 different headlines for a blog post, 2 different calls to action for an email, different subtitles. ChatGPT can generate these options quickly, allowing marketers to test different approaches much faster than writing everything manually. It can even suggest modifications to HTML button text, like changing submit query to get my answer or learn more. And in search engine optimization, SEO, it's very helpful. It can generate lists of relevant keywords for a website based on its content or target audience, like for Ad and Glove's e-commerce site. It can help you understand the intent behind different types of search queries. Is the user looking for information, trying to navigate to a specific site, comparing products, or ready to buy? It can even perform basic SEO audits on website code snippets, pointing out missing alt tags or suggesting improvements to meta descriptions.
Understanding search intent is huge for SEO, and analyzing customer feedback or sentiment. That seems crucial for understanding customers and improving products.
It absolutely is. For sentiment analysis, ChatGPT can process large volumes of customer reviews from your website, app stores, social media, and classify the sentiment expressed as positive, negative, or neutral. More than that, it can often identify the specific product aspects being praised or criticized, like great battery life or confusing user interface. This provides actionable insights for improvement. It can also be used to generate automated but personalized responses to customer feedback, adopting different tones, empathetic for complaints, professional for inquiries, maybe even humorous for a specific brand voice for use in chatbots or customer service replies. It can even summarize hundreds of reviews, highlighting the main positive and negative themes.
That's incredibly comprehensive for marketers. Okay, one more area, researchers. How is ChatGPT potentially reinventing the research process?
ChatGPT offers substantial support across the research lifecycle. For the initial literature review phase, it can act as a brainstorming partner, helping to formulate research questions. It can assist in searching for relevant academic papers, especially with web search enabled, and importantly, help synthesize findings from multiple existing studies. For example, you could provide it with the abstracts or full texts of 3 key papers on, say, social media's impact on adolescent mental health, and ask it to compare and contrast their methodologies, summarize their main conclusions, and maybe even comment on the reliability of their findings based on the provided text.
So it significantly speeds up that initial, often time-consuming groundwork.
Exactly. It can also help with experiment design. You could describe your research goal, maybe evaluating the effectiveness of a new project-based learning program in schools, and ask ChatGPT to suggest appropriate study designs, like a randomized controlled trial, RCT, explaining the pros and cons, and a task that plagues every researcher: bibliography and citation management. ChatGPT can generate properly formatted references for your sources in various standard citation styles: APA, MLA, Chicago, Harvard, you name it. You just need to provide the source details. That alone saves a huge amount of tedious work.
Oh, I bet. Citation formatting is the worst.
Right.
What about the later stages, like writing up results or presenting research?
It's highly valuable there, too. It can help structure the discussion section of a thesis or paper, suggest ways to connect your findings back to the literature and discuss limitations. It can help outline slide decks for conference presentations. It can even help craft compelling elevator pitches for explaining your research concisely to funding committees or non-expert audiences. It helps researchers communicate their work more effectively and persuasively.
This has been an absolutely fascinating tour through the capabilities. We've gone from the basics all the way to these really specific, powerful applications across so many fields. But now, you mentioned there's a next level beyond just using the standard ChatGPT. What are these custom GPTs or assistants all about?
Yes, custom GPTs, sometimes called assistants, are indeed the next level of personalization and specialization. Think of them as tailored versions of ChatGPT that you can create yourself, or use ones created by others designed to accomplish very specific tasks or operate within a particular domain. They essentially combine specific instructions, often much more detailed than a single prompt, with potentially custom knowledge bases like uploaded documents and a defined set of tools or plugins capabilities that they can use to interact with the environment or external services. OpenAI even launched a GPT store, a marketplace where people can share and find these custom GPTs.
So you can effectively build your own super specialized AI assistant for a particular job. That sounds amazing. How do you actually go about building one? What are the components?
It's surprisingly accessible, actually. You start by defining its core components, a name and a description so people know what it does. The real heart is the instructions section. This is where you provide detailed rules, guidelines, context, and persona for how the GPT should behave. It's like a very elaborate system prompt. You can also set up conversation starters, which are example prompts to help users get started interacting with your GPT. Crucially, you can enhance its knowledge by uploading custom knowledge files, things like PDFs, text documents, spreadsheets. The GPT can then draw information from these documents using a built-in RAG, retrieval augmented generation framework. So it's grounded in your specific data, not just its general training.
So you feed it your own documents to make it an expert on your stuff.
Yeah.
What about its abilities? Can it do more than just talk?
Yes. You configure its capabilities. It can have access to built-in tools like web browsing using Bing, DLE3 for image generation right within the chat, and the code interpreter data analysis tool, which allows it to write and execute Python code in a sandboxed environment, enabling it to perform calculations, analyze data from uploaded files like spreadsheets, create charts, and so on. Beyond these built-in tools, developers can define custom actions. Actions allow the GPT to interact with external APIs. This means you could build a GPT that can, say, check your calendar, book a meeting, query your company's internal database, or post code to a GitHub repository, basically connect it to other software and services. There's even an Actions GPT assistant that can help you define the necessary API schemas for these actions.
Wow, actions sound really powerful connecting it to the outside world. And how do you actually put all this together? Is it complicated?
OpenAI offers two ways to create them. There's a standard configuration interface with separate tabs for instructions, knowledge, capabilities, actions, etc. Or there's a more conversational building method in the Create tab, where you basically chat with an AI assistant, GPT Builder, and tell it what you want your GPT to do in natural language. It asks clarifying questions and helps configure the settings behind the scenes. It makes it incredibly accessible even for non-technical users.
That conversational builder sounds really cool. Can you give us some concrete examples of these specialized GPTs in action? How would they work differently from the standard chat GPT?
Certainly. Let's imagine a few. First, a personal assistant focused on fitness, let's call it Workout GPT. You could upload custom knowledge like an NSCA chart showing recommended training loads based on experience level. In its instructions, you'd tell it to ask the user about their fitness goals, current level, age, available time, etc. Based on the user's answers in the NSCA chart, it would generate a tailored workout plan. Now here's where the custom instructions shine. You could explicitly tell it, if a user suggests a clearly unsafe or overly ambitious short-term goal, like running a marathon in 3 weeks after recent ACL surgery, politely explain the risks based on standard recovery times and suggest a safer alternative phased approach. It's applying its specific knowledge and safety guardrails.
So it's not just following instructions blindly, it's applying domain knowledge and safety rules you gave it. Yeah, smart. What about for developers again?
Okay, imagine a data science assistant, GPT. Its instructions would prime it for data science tasks. Its knowledge could include best practice guides or internal coding standards. Crucially, it could have a custom action configured to interact with your team's GitHub repository. So a user could ask it to design a data science experiment, say, predicting Titanic survival based on passenger data. The GPT could outline the steps, generate the Python code using its code interpreter capability, and then using the custom GitHub action, push that generated code directly to a specified repository branch. It streamlines the entire workflow from idea to code commit.
That's incredibly efficient. And for marketers, could you build a specialized marketing assistant?
Absolutely. Let's picture a copyright companion, GPT. Its instructions would define a specific brand voice and style. Its knowledge might include company product sheets, past successful email campaigns, or competitor analysis documents you upload. It could have DELI enabled for generating visuals. A marketer could ask it to generate a new product sheet adhering to the brand voice, draft an email campaign targeting a specific segment based on uploaded customer data, using the data analysis tool to analyze the data first, create social media posts with accompanying visuals from Delhi, or even analyze competitive pricing data from an uploaded spreadsheet, generate graphs showing revenue trends or market share, using data analysis again, and summarize the findings in an executive report format.
Wow, that integrates multiple capabilities: text, data analysis, image generation. And finally, for researchers, how could a custom GPT help them?
Let's design a research GPT. Its knowledge base could be populated by uploading key research papers relevant to a specific project, maybe on image classification. Its instructions could guide it on how to synthesize information and identify research gaps. It could be configured with web browsing to fetch recent papers from sources like ArXiv. Maybe it even has a custom action to check or update a project bibliography stored in a Notion database. So a researcher could ask it, based on the papers I've uploaded and recent ArXiv preprints on image classification, what are the current state-of-the-art methods, and are there any promising techniques mentioned in my Notion database that haven't been fully explored? It becomes a powerful, integrated tool drawing from custom knowledge, web sources, and external databases. These examples really highlight how custom GPTs can provide much more focused, efficient, and often more accurate results than the general-purpose ChatGPT when dealing with specialized tasks and proprietary information.
What an incredible journey through the world of generative AI. Honestly, my head is spinning a little, but in a good way. We've explored everything from, the core definitions and the surprisingly long history to its diverse applications in art, science, business.
Uh-huh.
And now this cutting-edge capability with custom GPTs. It's really clear we've only just scratched the surface of what's actually possible here.
Indeed. It really feels that way. This technology is just evolving at such breakneck speed. It's constantly pushing the boundaries of what machines can create, what they can understand, and how they can interact with us and the world. And this ability we just discussed to tailor these incredibly powerful models to very specific needs using custom GPTs, well, it really hints at a future where AI assistants are even more deeply integrated and, frankly, indispensable in both our daily lives and our professional endeavors.
Absolutely. So as this technology continues its rapid evolution, here's maybe a final thought for you, our listeners, to mull over. What new tasks or maybe challenges, things you find tedious or difficult, might you consider delegating to an AI assistant in the future? How could that free up your own creativity, your own time for what truly matters to you? How might these tools reshape your own productivity, your own creative processes, perhaps in ways you haven't even imagined yet? Something to think about.